There we go. Welcome everybody to this week's presentation on quality testing and certifications. This is a huge topic, so we're going to dig right in. For those of you who don't know me, my name is Matt Rilinich. I manage the Innovation Works manufacturing programs. Also on the hardware team, we have Jesse Mazzoni, who manages the Alpha Lab Gear accelerator programming, and Mike Formica, who manages all of our hardware initiatives. Program is sponsored by NextCore. It's based on their manufacturing accelerator curriculum, which was sponsored by the NIST, National Institute of Standards and Technology, for the MEP network, Manufacturing Extension Partnership. It's a network of economic development organizations that are aimed at helping the manufacturing industry all across the United States. It was also sponsored by NISTAR, the New York State Division for Science, Technology, and Innovation. And the curriculum was co-developed by the Rochester Institute of Technology, Fuse Hub out of New York, and then our local MEP, Catalyst Connection, and the Innovation Works hardware team. So this week is the 7th week in the programming. First off, we covered product development and specifications. Then we talked about bill of materials and bill of process. Then we talked about cost modeling and risk management. We did an intro and an overview to quality with a heavier focus on prototyping quality. Today we'll be talking more about production quality. In week 5, we talked about design for manufacture and assembly and other variables that you might want to optimize your design for. And then last week, we talked about working with manufacturers and suppliers, negotiating, managing projects, all of that kind of stuff. So this is the second to last presentation, and next week we'll talk about considerations for scale. Welcome, Mara. So a bit of housekeeping logistics reminders. So in the first week, the homework assignment from that was to develop your own product requirements document, which sort of houses and links to all of the specifications that you would need to meet your customer requirements. Then we talked about your bill of materials and the different kinds of bill of process which might be used. And that's the homework assignment for those. The third homework assignment was a cash flow forecast, risk tracking document, and then refining your bill of materials and bill of process to make sure that it had costs or at least estimates for every component on them, as well as to be able to be ideally sorted as a percentage of the total BOM cost or BOP time cost. The fourth homework assignment was a prototyping quality test plan, and so we'll get a little bit more into the quality management stuff today. The fifth was to identify a DFX principle and what the first step would be to apply that to your design, as well as a sort of document for managing those types of changes or works in progress. And then the homework from last week was to list your current and potential suppliers and people you were considering vetting, as well as to complete the manufacturing tour survey, which I don't think anybody completed. So if you could go back and complete that, that would be great. We're going to try to organize some tours in the spring. So it would be really good to get feedback as to what you guys would like to see, who you'd like to visit, what you'd like to learn from those types of tours. Or just to say you don't care. So either way, it would be helpful for us to know. So we can revisit this at the end, but if anybody wants to share any problems that they had for the group, maybe people you had trouble finding or any capabilities that you're not sure where to look, I like having this group together. We've got a nice diverse set of experience here, but if not, we can also revisit that at the end. All right, we'll bounce back to this at the end. The other part of the homework was to revisit your prototyping quality test plan, because that can be a foundation for your ultimate quality plan for your product as you scale. And the important question to ask yourself is, have you documented the quality tests for each specification, which is critical, as well as your pass-fail criteria, sample size, criticality. This is stuff that we'll then again go over today, so it's just sort of useful to see the parallels. Remember, all of this is outlined in the curriculum outline on the Scalable website, and all of the recordings of past weeks are there. If you could, it would be very helpful if you filled out the feedback survey for each week's curriculum. If you have any things you'd like to add or things that you'd like to particularly point out that you found very useful, that would be very helpful for us. And then we also have a column in the curriculum outline for surveys to let us know if you weren't able to make any of these webinars and you ended up going and watching them after the fact. That's a really quick survey. It's just yes, I did, or no, I didn't watch it. It's very useful for us to understand, and it's also very useful for us to be able to document for those of you who received funding that you actually participated in all the curriculum, even if you weren't able to attend the live session. So just a reminder of all of the types of things that I would be happy to help you guys with if you sign up for my open office hours. And today we're going to break this up into a couple different pieces. First, it'll be production quality and testing, then certifications, including regulations and labeling, and then the overall sort of big picture of quality management systems. So I did not create this presentation, and I am not James Meyer. He seems like a really cool guy, though. These steaks always make me hungry whenever I see them on here, but just want to make sure I gave a shout out to James because he works for the Golisano Institute for Sustainability at Rochester Institute of Technology. They have a really cool facility up there. So unfortunately, they provide services for free to companies based out of New York State, but they provide low-cost services to other companies. So if you're interested in doing any type of sustainability analysis, it might be a place to look into. So today, this is broken up into a bunch of different chapters, which are each just sort of covered separately in the book. And it includes measuring, tracking, creating test plans, control plans, certifications, regulations, labeling, and then an overall sort of structure to your quality program is the quality management system. And then we'll wrap up with summarizing key takeaways. So quality is a huge topic. I know that personally I'm very daunted. I was very daunted even just to give this presentation. In one of a really good book, which is a semi-autobiographical novel about the author of the book, Robert Pirsig. It is called Zen in the Art of Motorcycle Maintenance. His personality fractures because of his obsession with philosophically defining what quality is. And so I think this quote encapsulates why it's daunting. So quality, you know what it is, yet you don't know what it is. But that's self-contradictory. But some things are better than others. That is, they have more quality. But whenever you try to say what the quality is, apart from the things that have it, it all goes poof. Comes out of your head. Love that quote. But we're going to try to break it down into different specific criteria here, and that's the whole essence of a quality management system. So at the end of the day, it's all about reliably delivering a product that meets your customers, that satisfies your customers' needs, but also their safety. And it also has a heavy impact on your company's reputation and also the financial viability of the company, both in terms of a just pure unit economic standpoint, but then also from a legal liability standpoint. So in chapter 2, they cover the product quality, and that's sort of what we had emphasized earlier. And that includes something that you'll oftentimes hear abbreviated as jargon V&V, which is validation and verification. Just to reiterate those definitions from the earlier week, verification means that you're making a product that meets your specifications as you define them. But validation is, did your specifications as you define them actually meet your customer requirements? And so this is really going to emphasize, this portion of the presentation really emphasizes more of the verification side of things. How do you make sure that your product actually meets the specifications which you documented, not necessarily whether or not you captured all the specifications necessary for meeting what your customer expects. And that's a very critical distinction here. And that kind of comes back to this question here is, what is the difference between production and manufacturing? And to me, that means production is whenever you are making anything. This could be a custom one-off piece or a prototype that has a limited lifespan and it's for a specific purpose. It's a more generic term. Manufacturing more specifically involves scaling a large volume, scaling to a larger volume in a repeatable way. So it's the science of making many things that perform the same way. And quality is essential to being able to do that. So in terms of the testing and the test plan, this session is all about how you document that quality plan and also when and where. So we oftentimes overlook that there are different control points in the process where you should actually have a separate plan for processing incoming components, and that quality plan might be different than the manufacturing or reworking of specific components, which would be different than the sub-assemblies and different than the final assembly. Your QMS system is what manages all of those and how they interconnect with one another, and it's the sort of one-stop shop. So when we start off, it's important to ask these critical questions, which is, how and what are you using to measure quality? How frequently do you do it? How does that information go up or downstream from any given quality control point? How accurate is the tests that you put in? How precise are they? And how can you be certain that the results that you're getting are legitimate to calibration? So we'll talk about an example here of measuring quality and the validity. I love this example because validity refers specifically to how well the equipment and the inspector work coherently. You can have the best instrument in the world, but if your inspector isn't following a reliable, repeatable procedure, you can still get error. Graduated cylinders are an incredibly accurate way of measuring volume of liquids. However, if you remember from your high school chemistry class, you have to measure at the bottom of the meniscus, and then you have to look at eye level with it. If you look at either down at it or up at the line, you will get an error in that. And so when you have many people trying to read and do this many thousands of times, those errors can compound and result in quality issues. There are also, it's good to know, type 1 errors, which are false positives, and type 2 errors, which are false negatives. And they need to be sort of treated differently and identified differently. It's something that we're probably all far more familiar with nowadays because of COVID and the proliferation of like instant at-home tests. But this is another thing that I remember personally from high school chemistry class, where we have these illustrations of accuracy versus precision. And precision is the ability to produce the same result many times, which is essentially whenever these dots are clustered tightly, they have high precision. Whenever the accuracy refers to how accurate it is, the measurement from a device is empirically. And so that is basically how close to the bullseye is it. So in this case, there is low accuracy. In this case, low accuracy. This case, if you zoom out and think about that, they're all clustered around the bullseye. So it's somewhat accurate, depending on your definition. But it's this one that you're always gunning for, which is accurate, high accuracy and high precision. Well, depending on if that's required by your sort of needs. So at the end of the day, there is a statistical process for identifying whether you are within your range for accuracy and precision, given the overall process. So that encapsulates both the equipment and the process which you operate the equipment. And it's called R&R, which stands for repeatability and reproducibility. It's not very difficult to do. You can look up tutorials on how to do this. There are formulas built into Excel to do it, or other statistical programs like Minitab. But the most difficult aspect about it is setting aside the time to actually do these studies, getting multiple different operators to test multiple different samples, all using the same piece of equipment, to then figure out if they're all using the same set of instructions and have been trained appropriately, how well does that training program function in addition to the piece of equipment which you're using. Calibration is something that many of you probably won't need to worry about. If you're utilizing a contract manufacturer, you won't need to worry about it in the sense of a logistics side, because you don't necessarily own the pieces of equipment that you're using. However, it's an essential part of any sort of regulatory compliance. And so it's a very good question to ask your manufacturer. How often is your equipment calibrated? By who? Most oftentimes, equipment is calibrated by the manufacturer or a sort of designated distributor of that piece of equipment. You can either send it away to have it calibrated if it's a smaller piece of equipment, and in that case, there are a lot of independent testing houses that can qualify any given piece of equipment, like a multimeter. But if it's a larger piece of equipment, like a granite block or a mass spec or a machine, a CNC machine, they'll most oftentimes come to you in order to put their stamp of calibration on it. And that is part of the whole quality management system that, if you're in a regulated industry, needs to be documented and tracked in your overall quality management system. Because, say, the FDA, for instance, when they come to audit you, they will be looking for that, or audit your manufacturer. So that doesn't necessarily mean that you can completely deny all responsibility for this. If you're using a contract manufacturer, they also need to be compliant. There are a lot of different ways to measure quality, and I feel like the natural inclination is to go to the most, sophisticated, simple digital readout piece of equipment that's available, and that oftentimes is an associated price tag. So at the end of the day, it really falls to you to understand what level of precision and accuracy you need, and whether or not there are other things like rulers and tape measures or dial calipers, which can actually be more than accurate enough, or something so simple as this old school analog voltmeter. Another type of gauge, which is very, very simple and oftentimes far more scalable for quality testings, is what you would call a go, no-go gauge. And you've probably seen something like this, like a battery tester, where it has measurements of voltage on there, but it's not necessarily that accurate. However, it is more than accurate enough for you to know, just, is the battery dead? Does it need to be recharged? Is it okay? Or mechanical go, no-go gauges, which would be this thing, to say, okay, we're going to test to make sure that the threads are good on these two components and that they fit, and then we can measure it from end to end with a pair of calipers to see if it is in the length tolerance that we need. So this is something Mara had brought up in the earlier version, which is, okay, it's easy in the early days to just test everything that you produce and everything that's coming in whenever your volumes are low. However, that's not a scalable solution and isn't really required. So this is called an AQL table, and it has become a sort of industry standard for setting your sampling amounts and the amount of defects you can have within a given subset in order to reach a given quality level. Like many things in manufacturing, it was actually developed during World War II as a method of testing bullets and determining whether they were of an acceptable quality level. So there are 3 levels of defects, and we'll get into this more later, but sort of safety critical, major defects, minor defects. And they have increasingly loose tolerances, so to speak. So 0 isn't even represented on this. This is actually just a subset of a table. AQL tables can be huge. But for a given lot size, say you ordered 1,000 parts, that would put you in this lot size, 500 to 1,200, and it gives you this sort of sample letter J. Then that means you need to sample 80 parts from that order of 1,000. And if you were trying to hit a typical major defect rate on the AQL table, you would be able to have 5 rejects, and that whole lot would still be considered acceptable. However, if you have 6 defects, then all 1,000 of those need to be rejected, because basically it exceeds your tolerance and you're not sure whether or not there would be an abnormal number of them that could cause safety or serious issues. Here is an example of the larger table. So if we're instead to say we wanted to get 1,250 units from this order, that would give us a sampling code of K, and we'd have to test 125 of them. Now, if you wanted to hit this defect rate, which wasn't on the chart earlier, of 0.065, which would be a really high one, there's not a level there. So you can't actually get to that quality rating with only an order of 1,250. You'd have to order more than that, or be able to accept a lower quality level. So if you inspected 125, which would be actually 10% of the 1,250, and you found no defective parts, then you could accept that and claim that you have hit a 0.1 AQL. However, if you found even one defect in that 125 that you tested, you'd have to throw out the whole lot size. These arrows here mean that it's basically 0 to 1 all the way down until you get to a sampling size of M. And if you're up here and you're trying to sample only at a sampling batch of 8, that means that if you're only making 2 to 8, you can never hit any quality level except for a 6.5. So that shows you right there that at a prototyping quantity where you're only making 5 at a time, you can never hit an AQL of 1. So if you're really having a safety critical part, you can't. You have to be able to produce larger lot sizes at any given time in order to be able to say that you're meeting that quality level. The same thing goes for down here. These arrows mean that if you have a lot size in the R, which is, well, there's not even R on here, so M, then at M, you don't need to sample 315 in order to hit an AQL of 6.5. You can actually sample less than that in order to hit that. What's up, Mike?
I was just thinking, I mean, if you have a sorry, getting a little bit of feedback there. If you had a lot size of 8 and you're trying to hit a particular quality threshold, wouldn't you just test them all?
Yeah, but this is a sort of the more statistical construct where you can't claim that you can produce more than that at a higher than that level of quality until you start producing more than 8 at a time. Good question. Yeah, good question. So now that I've actually just talked entirely through the table, we can skip over the last couple of slides here, but the ISO 2859 actually defines, ISO is International Organization of Standards. They put out all sorts of standards for testing and compliance and certifications. And their recommendation for using the AQL is that critical defects have an AQL of 0, major defects have an AQL of 2.5, minor defects have an AQL of 4%. And there's more specific criteria associated with that, and critical is actually broken into 2. So there is like a class 1 critical defect, which is very serious, leading to basically death or severe injury or catastrophic economic loss. And then a second one, which is just serious injury and economic loss. And they have different ones for that if you really dig into it. But the way that I like to think about these is a critical defect is something that is a significant safety concern or a sort of potentially destroy your relationship, put you out of business type of concern. A major defect is a destroys your relationship with that individual. It's going to result in a return of your product or it not functioning when it arrives. A minor defect is something like a scratch on the bottom or a non-customer facing side of it, which just shows that you have a sort of lack of attention to detail. It does more to erode your reputation as a company, but not necessarily resulting in a sort of return or a non-functioning product. So here's some more examples if you wanted to go through the table more on your own. But since we already went through an example, unless anybody has any questions, we can just go past this. Cool. So statistical process control, or SPC, is something that most early stage companies probably won't have to worry about, or honestly, if you're not in the business of being your own manufacturer, you won't really have to worry about. But it is a method of quality control and process control useful for continuous manufacturing processes, where you just set thresholds and each one is sort of measured as it comes off the line. This would also be a task for automation and a strategy for automation. If you were able to put a sensor sort of on your production line that could very quickly identify critical dimensions and then stop the whole production line if one gets outside of the range. And there is a statistical mathematical way of defining this, and you can see it sort of visually represented on here. If you were to imagine this is your lower critical limit, your upper critical limit, your target critical limit, basically. So there's a standard deviation threshold around it. And each one of these, you can see has a timestamp on it that it's being sampled as it comes off the line. And you can start to see that basically, who knows, maybe it was something like a temperature buildup or humidity that's sort of causing this line to so slowly creep. And then you start to hit that threshold, and this would result in the stoppage of a manufacturing line until you could identify what the cause of that was and bring the whole process back into tolerance. This would be pretty critical if you were producing like chemicals or something like that, where you would have to be able to then really document to the FDA exactly when those pills went out of spec and started to contain a lethal amount of something or a dangerous level of some particular ingredient. Again, it's useful in some manufacturing processes, but you have to get pretty high volumes to justify that. So now that we've covered the sort of how and why of measuring quality, it's important to talk about where we do it. So now that how do you make the measurements? Where are your control points in the overall process that allow you to be certain that, as we talked about earlier, all of the components coming in or the materials that you're buying are within spec before they get into your fabricated parts, and the fabricated parts are in spec and are performing as the sub-assemblies should before they get into the assembly process. And that's where the sort of process flow diagram is very useful. And this can be built off of, or actually even precede your bill of process flow diagram, because it can be pretty generic. But you can see it on this one, all of the ellipses, I was going to call them circles, but that would have been embarrassingly inaccurate, stand for a quality control point. And so as these PCBAs are fabricated, there are quality checks in the process. We'll talk a little bit more about these types of inspection processes later, Same thing with the fabricated components. They go into your different assembly stations, which are checked individually. They kick out for rework to go back to the assembly station, and then auditing before producing finished goods. And then, so these all look like things that they're ordering. So packaging, you can imagine, is like cardboard boxes or packing materials. Semi-custom parts or commercially available COTS, commercially available off-the-shelf components, they're listed here. These things are all sort of inbound inspection, which is something that I would definitely recommend putting into place, and it's something that's very easily overlooked before they ever get used in any assemblies. Oh, look at that. Incoming quality control. That is a list of all of the ways in which that could become a problem for you if you neglect the inbound quality control. You're going to spend labor on it. And then also, depending on the type of process that you have, if you're potting something, like where you fill it with epoxy so that it's completely waterproof, then you have to waste all of the other components if you found out that one of the components that went into it was bad and you could have tested it ahead of time. So it can really impact the cost of goods sold, but also the cost of carrying the inventory if you end up. This sort of just happened to me actually, where I received my big shipment and one of the pallets had fallen over and half of them were all smashed up. Fun fact, only have 24 hours to make a claim on any inbound shipment that you get if you want to claim reimbursement from an insurer who insures the shipping carriers. So it's really important if you're getting a truckload of stuff to inspect, at least your representative amount of samples that you want from that to make sure that they're not damaged because the day that you get it. So production quality test plan. This is also going to look different for fabricated components. Things that are coming from an outsourced fabricator, like a PCBA house, a electronics contract manufacturer, they will likely have their own system set up to do those tests. However, you want to make sure that those tests are actually defined according to the parameters that you need them to be. If they just go with some industry standard without understanding exactly what the functionality of your product is, you'll then be left with a bunch of parts that might not work, and the manufacturer will be able to say, it doesn't matter, that wasn't the scope of our agreement. And that's a worst case scenario. A best case scenario is you don't want to ship these out to your customers and have them not work. So you have to then set up your own quality control on those parts inbound, which makes it basically more of a internally fabricated part at that point. So FAI is a common industry vernacular, stands for first article inspection. And this would be typical of whenever you're first setting up a new contract manufacturer, you're paying for tooling or setups, things like that. You'll want to do a pretty low sampling rate at first, because you don't want to order 100 just to hit an AQL level right off the bat. They're making them for the first time. It's totally reasonable for you to say make 5, and then I want to inspect all 5 of those. Another really critical thing that I've just pulled from my own experience is if you're relying on a manufacturer's quality department to test things, make sure that you have a full understanding of how the thing is being made. Are they using one assembly line, one piece of equipment for every step in that electronics process? Or if you're injection molding something, does your tool have 1 cavity or 6? Are they testing each cavity for those first article inspections or any sampling AQL that they give you? Or are they taking the whole lot size? Because you could have 1 bad cavity and they just happen to randomly be pulling from the other 5 cavities. And then you end up with a 1/6%, 100% defect rate purely because you didn't track which part was coming out of which cavity and test them all individually. So very important for you to understand sort of how the thing is made, even if you're relying on an outsourced quality program. So some specifics on electronics testing, electronics quality control, some industry standard stuff, which you'll find in pretty much any PCB house, is AOI, or automated optical inspection. And so this is literally a vision system. It's just a camera that takes a picture of every board as it goes through. And that can identify sort of bad solder joints, orientation of components, making sure that the right component is placed on that board, because they're usually stamped with like a part number and a serial number right on the top of them. And it's useful as a minimum check, and it can do a lot of pretty important functional tests. There's oftentimes that manufacturer won't rely entirely on the automated inspection system, and they'll still have an operator there sampling every once in a while to make sure, or they have the thresholds of it set very low so that it kicks out if there's even the slightest chance that there's like a cold solder joint, and then there's an inspector there just standing clearing the parts and saying like, no, the computer thought it was, but it's not. ICT is in-circuit testing, and that's what this sort of thing is a picture of here. This is where you have a bed of nails that comes down onto specific points on your circuit board to test. It could do any sort of testing, basic or complicated, resistance, conductivity, inductance. You can even do like functional performance testing or gain of different like amps or actuation of transistors, all sorts of different things. But at the end of the day, your manufacturer needs to know what is actually critical to the functioning of your device. Otherwise, they're not going to be able to suggest the creation of these test pads to even utilize this system. So that really comes down to your specifications document. I also would say advise on the other side of that. It's not necessarily a great idea for you to go overboard if you are designing your own schematics or circuits to try to design all of that stuff in, unless you have a pretty substantial amount of industry experience, because the manufacturer itself probably has more experience designing these types of things based on the availability of the equipment they have in-house. So it can be very useful to communicate and to rely on them. Then there's the more basic sort of functional tests. When it comes out, does a light blink? Have you designed a light in there to indicate whether or not it's getting power, or a blinking sequence if there's an error? You can write that into your SOP as to saying like, you know, I want to have somebody on the assembly line check that this works. And then just fit component subassembly testing. If you have something that has like a port on it, is it actually aligned with the enclosure so that you can get a USB or a charging port in there? Because it is possible for those jacks to like get misaligned or bent during assembly, things like that. So quality, remember, quality isn't limited to just the parts, but it's also the process, and it must be ongoing. So something as trivial as just shipments. Where do your shipping labels come from, and how do they get to the fulfillment side of your business? And is the right SKU being shipped for the right person with the right shipping label? And there's a lot of different ways of doing that. But like, I mean, for instance, just, you ever wonder why you get a packing list in a box that has only one thing in it? You're just like, this is a waste of paper. The reason is because the person who shipped that is probably shipping a bunch of things, and that packing list was attached to the shipping label, so that that's what the person who literally, what they call picked your order, got. As they say, okay, what's on the packing list? I picked this off the shelf, put it in the box, close the box, and then put the shipping label on it. And that way you know that you're shipping the right product to the right person. And that can be a critical KPI or a key performance indicator for your business as a financial process. And that's something that you, maybe once you get the system down, you don't need to scrutinize it too much, but it's still always a good idea to have ongoing testing for any of these sort of human error type situations. Now, this is another thing that your control plan, depending on your particular method of manufacturing and your part and your manufacturer themselves, it's probably not something that you're going to have to worry about, but it's something that's good to ask about. So this is an example of a sort of die casting process. And this is a peek behind the curtain of what a good quality manufacturer should have in place, which is when they set up a machine to start running your, say, instead of die casting, say, injection molded parts, they should be doing all of these checks to make sure that the material temperature is within range. How is that temperature range measured? An immersion parameter. How often is it measured? And then what happens if it's out of this tolerance band? Injection pressure should be this. It's a sensor from the machine, once per shift, etc. And there's basically just a whole list of all of these things that go into something which you think is probably very trivial, but it should be in place. This is probably something that you would run into more whenever you get into the prototyping side or working with freelancers or very new or very small manufacturers that don't have a sort of sophisticated system in place for doing these things. Maybe they aren't calibrating their equipment ever. And so you start ordering with them and everything is fine. Nothing changes over time. And then suddenly you're getting a ton of defects and you don't know why, and neither does the manufacturer. This could be a good thing to remember is what is the industry standard for any given manufacturing process, and what is an appropriate control plan for that procedure? Are they following it? Because it is possible that they just might not know. So now we'll move on to the certification side of things. This is where everybody's mind usually goes whenever you start talking about quality, is you only want to do it if you have to. It's always a good idea to do it, but it always seems like a much better idea whenever there's somebody with a big stick waving it at you and saying, hey, you've got to do this or I'm going to come and make sure you do. It's an alphabet soup of all of the different types of certifications out there, the testing houses, the different things that they're testing for. And the biggest struggle is knowing where do you even start. One good place to start is with Underwriters Lab, or UL for short. We'll talk a little bit more about this in a minute, but I think taking a step back, from my perspective, it's really useful, especially if you're not familiar with this, to understand from a big picture, what do regulations, certifications, standards actually mean? And I created this for our Alpha Lab Health medical accelerator because it's a really, really good best practice scenario. Like the FDA, any highly regulated industry like medical devices, nuclear, defense, hence the whole MRL process, aerospace, stuff like that. That's like your top level. They're going to have everything spec'd out, and they're going to want you to do everything by the book in order to to pass their muster. And then when you go down from that, there's sort of Department of Transportation is a next level of public safety, as well as sort of civil engineering and building structures. And then you go down from that, and it's food, ironically. So food has a lower level of regulation than transportation. And then when you go below that, that's when you get into consumer product stuff. I'd say actually the FCC is probably at that level of Department of Transportation. And that's because, if your device emits an electromagnetic signal, it can cause direct or indirect harm. Indirect harm by interfering with essential communications, which could be saving somebody's life, or direct harm, which is the typical worst case example that you hear about, is stopping a pacemaker. So you sell an electronic widget that just so happens to be sold to somebody with a pacemaker, and it stops their heart and they die. That's why FCC is sort of a bit higher than food, because it's a more acute problem. But generally speaking, regulations refer to laws, and they're oftentimes denoted with this CFR abbreviation, stands for Certified Federal Regulation. And it is like on here in this example, 21 CFR Part 807. There's actually a little weird abbreviation for CFR that makes it look like one symbol, but it's just denoting a very specific subsection of a law that was passed by a legislator. And it states the specifics around what a manufacturer needs in order to be listed by the FDA, both foreign or domestic suppliers, as a medical device manufacturer. 21 CFR Part 820 is what outlines the specific requirements that need to be in place for a quality management system, and what the FDA is going to inspect whenever they come to audit you to make sure that you're following their laws. ISO 13485 is the certification, which you will see denoted on manufacturer's website. They tout it very proudly because it's a lot of work that they have to do in order to prove to the FDA that they are compliant with this law to get that certification. That basically just means that they have all the processes in place so that you don't have to worry about it. However, in order for them to maintain that, that's what also means the FDA will come visit them, I think once a year. Mara can correct me on that if I'm wrong, to maintain that level of certification. ISO 9001 is another quality program, which you'll hear very commonly referred to. And that is just a general quality program that says they can make quality parts and they can give you all of the data that you would need. It's like one step away from 13485. And then in between, there's ISO 9100, which is an aerospace quality program. And it just has a bit more subtleties related to sort of things that fly as opposed to things that touch the body. Another really interesting structure that I find very helpful to think about in terms of medical devices is that there's these other acronyms, DHF, DMR, DHR. DHF stands for Design History File. And this is everything that we've talked about to date. This is all of the digital information that describes your design, your specifications, how your device is supposed to function and what operating conditions, everything about it, and every change that you made in getting to what the latest version is. This is something that you have to have and you have to maintain in order to maintain compliance with these laws. Your device master record is the sort of manufacturing side of that. So if the design history file is purely digital, it represents only the designs and the theoretical product. The device master record represents how did you make that product, all of the work instructions that are necessary to build it, and then all of the testing protocols that are necessary to verify that it meets the specifications in your DHF, your design history file. And then the sort of bottom of that pyramid is the device history record, the DHR. And this is literally every single product that comes off of the assembly line and goes out into the world needs to be uniquely identified with a number that's sort of indelible to that, so that if it fails to function or kills somebody 10 years down the line, it can be traced back to who made it, when, and what version of the DMR and DHR were in place at the time, and when the last FDA audit was, to prove that it could have been or couldn't have been caught at the time. So who is at fault? That is your sort of best practice situation, and that's why I sort of say that's why it gets very expensive when you're in highly regulated industries. It's still a good idea to do that even if nobody's going to come looking for you, because you never know. The unknown unknowns can come up and creep up on you, and you can cause a major problem down the line. But if you don't have that information organized, it can be incredibly burdensome to try to figure that out. And if you don't figure it out, you could be legally and financially liable for the whatever result you didn't intend to have. Did I cover everything on here? Yeah, so regulations are laws. Certifications are denoted by numbers, which are issued by standards or through standards from different organizations. So you'll see ISO, IEC, SAE, for automotive, Underwriters Lab. They're organizations that literally write down all of the rules, requirements, and tests and how you perform those tests in order to meet a certain standard and in order to have a certification, aka the label that goes on the website or on your product, to indicate to regulators, the organizations that enforce regulations, that you are compliant. Yeah, so regulations, I gave the example in the medical device world, and CFRs, which are certified federal regulations. Those are federal laws. They also exist at the state level and then at international levels. Now, UL is pretty dominant in the United States, but CE is another one that you've probably seen on any electronic product. Oftentimes they are co-branded on there because people who sell or distribute things in the US don't always recognize CE, even though CE and UL pretty much compete head to head to have all of the same standards that meet all of the same quality control processes. It's really just a question of, does your market actually know about them and accept them? That's why most people have both. UL is more common in the US. CE is required in the EU and many other places in the world. Sometimes people will accept one or the other, but a great place to start is UL. I haven't done this myself, but from what I've heard, they're actually pretty helpful and responsive, that you can set up a meeting with them better earlier than later, that they can actually walk through your product requirements, specifications, your market that you're selling into, and they will tell you sort of what they think you should have in terms of tests or certifications, which they can provide. And then at that point, they will attempt to sell you on their services. If you want a UL mark, nobody else can give you a UL mark but UL. However, you can pay third-party testing laboratories to do the tests that are defined by UL, so that, for instance, in a consumer market, you can sort of say to your board or your stakeholders that you're compliant with this, but since nobody's actually going to come around enforcing it, you'll have that documentation internally that you perform those tests according to those standards, but you don't necessarily have to pay the premium to be listed in UL's database. Another really interesting aspect of that is, if you look at like any device you buy on Amazon, particularly electronics that are shipped in from China, power supplies, whatnot, you go to aftermarket or the cheaper side of things, they'll all have UL and CE marks on them, but they're not all real. They just sometimes either put a random number or they copy and paste from somebody else's power supply. So you can go to, that's what the value of UL is. You can actually go to their database and look up any number and see if it matches the type of product. Might be difficult to determine because, you know, various holding companies and distributors and stuff like that. But if it's, you know, you bought a power supply and it's for a radio, you'll find that it's probably not a legitimate mark. So oftentimes we hear that certifications are extremely expensive, and they can be, but it's always better to start earlier because it can help you to, number one, budget for it, but also to catch things that might be very expensive to put into place later. If there were a requirement from the get-go, it's a really good idea to start having those conversations, and basically in the language of the MRL, set your phase gates appropriately. You know, understand your risks and accept them, and move forward, or, you know, go back to the drawing board and figure out how you're going to meet those requirements. There's a thought that totally slipped my mind there. All right. I'm sure it will come back to me. Almost had it. What was it? Never mind. We'll figure it out later. Somebody will probably ask me a question about it. So labeling is the other side. Oh, that's what it was. So in order to get a certain certification, I am not entirely sure, and it probably varies depending on the particular certification and the particular test they perform, but you will need to have a solid manufacturing process in place before you get to that level of testing. There are certain things that can be easily swapped in and out if you move from, say, for instance, from like a reaction molded enclosure, something that like is a silicone mold and polyurethane that meets your exact same mechanical tolerances and wall thicknesses and whatnot as an injection molded part. You can potentially get through certification without the final enclosure, but that's not always the case. And that can vary from FCC to UL to CE to different tests that they provide. And really the only way to figure that out and what your sampling requirement is, you might need to send them 5 samples. You might need to send them 1 sample from every production line. You might need to send them X number a year over a period of time. It's going to be different, and you have to just talk to them about it, because it will also be different depending on the organization that you're going for. But these are some common marks that you probably recognize. There's the UL mark here, certified UL, and then there is the number, which shows what that it is listed in their database under there, and so they can find your company information by looking that number up. I don't know if I see FCC here. There's CSA. There's a whole bunch of different marks for US, for Canada, for US and Canada. It's very subtle, and there's a lot that goes into it. I would not necessarily take my word for it. Take the word of an expert on it. I recommend having those conversations. And I had another thought, which also just slipped my mind. Oh, how do you find out where you go to get certified, what certifications you need? It's a good idea to figure out sort of what industry you're in, and if that industry is subject to any industry groups like the Society for Automotive Engineers. If you're making an automotive product, then they would be a good resource to figure it out. Looking at comparable products, something that has a similar, sells into a similar industry, performs a similar function, has similar power requirements or communication protocols, any of those things that are sort of material compatibility. Does it touch the body? Does it go inside the body? Does it emit radio waves or receive radio waves to communication? Does it plug into a wall or take power? Does it use batteries? Does it have a mechanical safety component? Does somebody's life depend on it? Those are all good questions to ask. In addition to UL, or just talking to UL or a nationally recognized testing laboratory, often abbreviated as NRTL, you can also talk to an insurance underwriter, because at the end of the day, what you are trying to do is prevent hurting people. But what happens if you hurt people is oftentimes a lawsuit follows, and you carry insurance to pay for that lawsuit. So somebody who is very much incentivized to make sure that you are doing everything by the book is the person who's committing to pay for any damages on your behalf. So talking to an insurance underwriter, making sure they have a real full understanding of what the scale of your operation is, the operating environment, who's going to use it, and what the potential hazards are. They will oftentimes have experience, provided that they work with similar companies at similar sizes and similar markets. So make sure you ask them that too, as who they've worked with in the past. They can also give you some pretty good advice. And it's a similar situation to UL, where they're obviously going to try to sell you something, so they're sort of motivated to help you solve your problems. All right, so now pulling this all together into that quality management system. This quality management system has been in place, since to some degree or another, since World War II. And it's been refined all throughout the 90s whenever computers were really just glorified filing cabinets. You can do it with a filing system, like a file cabinet full of papers with all the appropriate document numbers that reference one another and their sort of Dewey Decimal Card catalog. You don't have to do it that way. Shared drives and the internet make all of that very much easier to do digitally and to collaborate across large distances. But there's also a massive variety of software out there that can do this type of stuff. Everything from more simplistic software as a service programs all the way up to the enterprise suite of software. The big ones like SAP and NetSuite. So recall the quality planning from the intro to quality side. QMS governs all of this stuff. How do the documents connect? What are the policies and procedures for every step? What is your quality mission? Critical factors to success. And then also the FMEA, failure modes and effects analysis, that we talked about in the intro to quality side. This is a good time to revisit that, dust it off, and see if you've captured sort of everything involved. So when is a good time to start thinking about all of this stuff? I would say it's a good time to start thinking about it as soon as you have the idea. Because one of the most common refrains that I hear from people that we work with is, I really wish I would have listened to you when you first told me about this, because now we're so deep in the process, I hate going back and redoing this. It would have been much easier if I just started in the first place. I think it's a natural human instinct. It's easier to say that you'll do it later, and that it's too much work to revise something that you've started but isn't actually complete. But at the end of the day, I would highly recommend understanding the best case scenario or worst case scenario, depending on your perspective, of like the medical device. Recreate your device master record, your design history file, and your device master record, and sort of emulate those things, even if they're just Google Sheets with links to shared documents. There are a lot of formalized systems and processes out there, and there's a lot of codified quality improvement tools and continuous things. You've probably heard of Six Sigma, maybe the Taguchi method. There's ones for software out there. There's ones specifically for manufacturing out there. They all sort of basically follow the same ideas and putting into practice the framework of a quality management system. But the thing that I really like is this. So it helps me to visualize things, and this is what a quality management system is to me, and it's a pyramid. So at the base of the pyramid, you have all of your records. This would be, your spreadsheet that has every serial number of every product that you'd ever produced, the testing records for every quality control point that you test anything in, and how that correlates to each part. And at the top of it is your QMS manual, which defines where do you find all of the different documents so that there's not something that's orphaned, and how do they relate to one another. If you think about a old school nonfiction book with an index at the back, where it's like every time something is referenced in one manual, it should have a list of where it was listed in there and then where it relates to in another part. So then thinking about them in terms of processes, procedures, work instructions, and records are the various different sort of components of the document types that would all be managed by this system as a whole. Some famous scary stories about recalls and how much they cost. They could have maybe saved money if they were able to identify things. Dell's laptop batteries, the Tylenol, what was it? Acetaminophen. poisoning the GM ignition switch, which we talked about last time, $4 billion. I did not realize that I have a Samsung Galaxy. I had one at the time that this happened, and I didn't even bother to check if mine was subject to the recall. Did not realize it was $5 billion. But yeah, these things can get huge when you are a huge company, especially. So, but also, I had a note here. This is what the FDA audits whenever they come to visit a 13485 certified manufacturer. They literally say, show me your filing cabinet. Now let me check that you have all of these things, and let me check that they're all linked appropriately. Let me check that your records for this particular company are in order based on their actual purchase orders and history of what's out in the world. So getting into the sort of homework for this section, there is a template in the folder that has an example of a failure modes and effects analysis. To recap, we talked about this a bit earlier. There is at the end a sort of severity ranking, an occurrence detection, and then a risk priority number. So by multiplying these three numbers, all scale of 1 to 10, how severe is it? Insignificant to number 10, catastrophic. Occurrence, how likely is it to happen? How frequently does it happen? 10 is inevitable, 1 is extremely unlikely. Detection means how often do you expect to be able to catch it if it does happen based on your testing protocols and equipment that you have available to you. 1 is certain to detect, and 10 is there's absolutely no way that you'll detect it. When you multiply all those things together, you get your risk priority number, which means that the higher that number, the more likely you should make sure that you have a plan in place to identify, catch, mitigate those types of failure modes. So this is a document which you'd want to put in place once your design is fairly finalized, and it's going to be heavily based on your requirements in your operating environment as to what type of harm you might potentially do and what you're trying to mitigate. So in putting these types of documents into place, here is a list of steps. So first off, identify what those failure modes are, determine their severity and the likely mechanisms for them, then identify how you're going to detect them and control for them. You can use your RPN number to sort of prioritize and schedule how and when you're going to address some of these things, because it is possible that some of them are going to be so minor and or so infrequent that you don't necessarily need to address them. But that's going to be ultimately a judgment call up to you. There's also a template for the control plan, which this is that one document which we went over earlier, which I said is sort of like more on the manufacturer side, but it can be applicable for you in any of the processes you have in place. So everything that I had listed was very complicated for like an injection molding machine with all of the different process parameters that go into it. But this could be something as simple as your shipping process, where it's, how does an order get shipped? Who is involved? And how do we know, and when are we going to test to make sure that it's actually functioning at what level that we're good? And then the sort of generic side of this is, we talked about it earlier, where it's like quality can be anything from not killing people to just not eroding your company's reputation. And those are I don't want to call them judgment calls because I led with not killing people, but these are the philosophies that you need to put in place so your company understands what do you stand for, and then also your customers. So it's useful to sort of have a quality mission that encapsulates what you're trying to achieve with all of this paperwork. So key takeaways: quality is all about measuring, tracking, codifying all of that in a test plan so that you can show that to regulators and get certifications to prove that you know what you're doing. And that is organized and encapsulated in your quality management system. So other homework, yeah, a summary of the homework is that define your quality mission, take a look at your failure modes and effects analysis, and see if it's a process control plan is appropriate for where you are. And then if you want to read more information on this, there's chapters 13 and 17 cover all of this stuff in greater detail. And you'll probably still need to go into greater internet researching detail depending on your specific industry and problems. So, any questions? Well, cool. If there are no questions, thanks, Stephanie. Yes, thank you for the link to the tour survey. That's what I was going to say. At the end of this, I will put these links in the chat. Where did I put them? Stephanie, what's up?
Can you put up the slide again that said everything you could help us with if we wanted to schedule office hours with you?
Yes. This one.
Thanks.
Yeah, no problem.
On a related question, Matt, what is kind of the timeline for getting your assistance with this sort of stuff? Is it only through the end of this year, or will we have opportunities to work with you in 2023?
Yeah. So sorry, echo there. I am grateful for the opportunity to work for Innovation Works, and given that we're state funded, I will maintain my office hours calendar pretty much indefinitely. The amount of available hours will probably flex depending on the time of the year, but yeah, there will always be an opportunity for me to go through this stuff. It's just going to be chunked out into the specific 20 to 30 minute blocks. So I ask that send me something in advance, and if it requires time for me to look through it, send it ahead of time, and then put the time on my calendar where we can sort of walk through it and make it very actionable. Because some of the stuff that I even put on here is like identifying gaps in documentation. Like that requires some time for me to set aside to actually review the documentation in order to provide any meaningful feedback. Not really possible in like the 20 to 30 minute window, but if I can get a good understanding of what specific need on a specific document is, then that's the sweet spot. Good question, Adam. The other thing I was going to say that I wanted to revisit at the end was I always find that supplier discussions are really useful. Mm-hmm. So if anybody has anything they're struggling with or wants to share, suppliers that they really like or manufacturers that they've worked with that they really like, that might be useful to other people in the group, I think that would be a good discussion.
On the electronics side, I had the opportunity to visit EPD Electronics and also Matrix and Dynamic. They have two groups, and both groups were very well versed in everything medical device related, industrial related. So they're well versed on everything we went through today, the whole quality system, how to test everything, how to record everything, how to get through audits, all of that. So they were both super helpful and great pricing. That's my contribution. And then on the need side, I'd love to know if anyone has identified any great mold manufacturers, not injection molders, but the actual manufacturers of the molds in the US or Mexico or somewhere other than China.
Oh, that's definitely.
Sorry about that. We've used the Technology House for our mold making. They have locations in China, but I think they also have options in different geographies. I can reach out to them and ask you and see if they can accommodate non-Chinese molds if necessary.
Thank you. That would be great. Yeah, we're just trying to avoid any issues with Chinese New Year's.
I believe we've used Zebraform in the past, and they have domestic. And I think their headquarters is in PA.
Thanks. Yep, I'll check them out too.
Yeah, I think they're in Erie. But it's also a good strategy is also to ask the injection mold shops who they've utilized in the past. Sometimes they have like sort of exclusive relationships that they don't want to give that out, but other times they're people who are just like, no, this is my lane. I only inject the parts, and they'll be happy to tell you. Fictive is another one that they have that sort of distributed manufacturing concept where they, from what I've heard over the years, have shifted more and more to Asian suppliers because most of their demand comes from people who are price sensitive, but they do have a component that's domestic. It also might be an interesting thing that you could use MFG.com for, because MFG is that marketplace one where you just post your job and ask people to bid on it. And since most of the engineering around producing a tool also comes to understanding what type of part geometries they can handle. So if your part is already designed for injection molding, you should be able to just post that and what materials you want to use, and that would be enough for somebody to quote you on what the tool would cost.
Perfect. Thank you.
Yeah. Anyone else? All right. Well, if nobody's got any other things they'd like to discuss or questions, we'll return these 7 minutes to you. And get some lunch. I haven't eaten anyway, so I hope everybody has a great week. I'll see you again next week, same time, same place, for the last presentation, which is considerations for scale, and that is sort of the catch-all for all of the other things which might crop up as you scale. And that's a little bit of certification, a little bit more on certifications and labeling, as well as testing, shipping and logistics, MRP and ERP systems, all of that kind of fun stuff. All right.
Thanks as always, Matt.
Yeah. Thank you guys. I appreciate the engaged audience that you guys always are. So have a great weekend.
Thanks,
You
Matt.
too.
You too. Talk soon.
Bye.